to go over some quick concepts for some of the stuff we've done with SaltStack. SaltStack is a configuration management tool we have used at 6 Feet Up for a lot of our projects. We've been a user of SaltStack since the early days of Salt, probably 0.10, which probably puts us in the old people's category of how long we've never been using that specific technology. But some of the things I liked about it is that it is a Python-based configuration management tool that gives us a lot of flexibility for doing event-driven orchestration. So for folks who are familiar with the cloud, obviously you've got the AWS CloudTrail and CloudWatch events, things like that. SaltStack actually has that and has had that probably before a lot of the cloud providers had that. So I will be looking over here into the group chat. I will just kind of give, to start with, we've only got about a half an hour, so I will give a quick just intro to some of the concepts and terms around the configuration management and orchestration with SaltStack. So I'm going to share my console here. There's no fancy slides, so you don't have to endure a crazy slideshow type thing. There's no sales pitch. It's just going to be literally me and a terminal window with some tmux and some vim, and any Emacs people in the room can just cover their eyes so that they don't see what's going on here with vim in my console. Okay, so I'm actually going to take an existing customer and kind of just take you through a tour of some of the things that you can do with SaltStack. Again, this is super informal. Please pepper the channel with some questions. Actually, I'll make sure I'm watching the Slack channel as well over here. Uh-oh, I see we've got the people who are already commenting about the VI versus Emacs in the channel. But we will trudge forward. I'm definitely a longtime VI user. I know some folks on my team who disagree with me. A Salt project is typically made up of states, and states you can think of as the template for how you want a system to be. So if I said I'm building out a load balancer, here are all the things I would need. I would need to install HAProxy. I would need to lay down a configuration file. I would need to configure the origins for the back end of it. That templated piece is all put into a state, and the values that you insert into those templates come from what's called pillar inside of Salt. So you see I've got a directory here for pillar, I've got a directory here for states, and if we look at the load balancer, you'll see that this is just a YAML. So anyone who's familiar with Ansible or other kind of modern configuration management tools will recognize the YAML going on here, and it has nice support for dependencies. But what is nice is that we typically will put in here some variables so that we're not actually hard coding into our states a lot of the values. Now, this one could be refactored, maybe made a little more flexible for other platforms. But when it comes down to actually like loading the values into that backend, if we go up here and look, we have pillar data that matches up to that load balancer. And then I'll have in here just basically a dictionary with lists of data. So I'll populate the backends for my load balancer. I will add in some rewrites, and then all the magic happens so that basically for every environment, you can see here I've got a dev, a local, and a prod environment that are in here. Those can now have different values depending on what's supposed to happen in each of those various environments. So that is pillar and states information inside of SaltStack. What I find even more interesting about configuration management and orchestration tools is that this one is different than other tools like Puppet or Chef or Ansible in that it has a full event-driven bus behind the scenes. So you can listen for events happening and then react to them. Or you can do orchestrations based on things happening in your environment. Now I'll just show you a quick couple orchestrations, because a lot of times you've got less technical folks who maybe want to release code, for example, to their environment, but they don't want to know about like Unix system administration. They don't want to understand that there's a cluster of servers. They don't want to have to like SSH into all of them. And we definitely don't want them like fat fingering configurations. I mean, I think that's how Amazon S3 had one of its biggest outages, was someone fat fingered a command line tool. And we ended up losing the index for all of our data in S3 for I can't remember how many hours, but that was a huge event, and we want to try and avoid those things. We basically want to put in place some push button pieces so that people can do their own code releases, do their own code statuses. So for this one, I'll just show you quickly like how we do a code release for this. And basically just think of it as the set of steps you would go through in your normal day-to-day process for releasing code. So I'm going to go in here to code release, go to the top. Actually, before I go there, oops, that was code status. Before I go to the code release state or the orchestration, I wanted to show you the code status one. Sometimes you don't want to move forward unless, oh, nice socks. It's awesome. So sometimes you don't want to move forward with a release unless things are already in a state that you agree with. So for example, maybe the load balancer is active, all the backends are live, maybe all the application instances are running. You want to know things like what code hash is currently released, what code branch is currently in that environment. So we support releasing into, say, like the local environment, the dev environment, the production environment. If you run this status command, it will tell you, hey, you're looking at dev, and yes, indeed, the code branch is dev. Here is the hash for the current code on the file system. So for example, if you needed to roll back from a botched release, you have that data available to you, and you didn't have to go, figuring it all out. So if you actually now, this code status is doing that exact same thing. It is taking us through our status. So it looks at supervisor. So our application is currently running on our application servers using supervisor D as our application runner. Salt has built-in support for a ton of different tools and platforms, and luckily it has native support for supervisor, which makes it really easy to write these kinds of orchestrations. So we just tell it we're going to run supervisor D status, which is a Salt module. So I've talked about states, pillars. Salt modules you can think about as cloud functions. Like you can run a function against a machine and you'll get back in return data. We target a specific set of machines. In this case, we're using the env name, so whether it's dev, local, or production as a variable, it allows us to target. And we can use the same exact script across all three of our environments. Well, it's not script really, but orchestration. Now we do the same thing. It's got support for get. You point it at a directory. You tell me the current branch against a certain machine, and it'll output that data for you. And then same thing for hash, for the version hash. That way I can see what version of code is actually laid down on the file system. So now that we're happy with the status, I'll show you the code release process. So the code release process is a little more involved up here at the top because we're setting up a lot of environment variables, and we're also trying to do some figuring. We want to know that, where are the load balancers, where are the app where is the app servers, where are the database servers? Because, for example, we want to do things like release code across our application servers, but in sequence, take them out of the load balancer, release the code, put them back in the load balancer, move on to the next machine, take it out of the load balancer, move, put it back in there and go at it again. So that's why we're trying to find the load balancers for that environment, find the app servers for that environment. That's what these little runners are doing here. Basically, is another concept I'll introduce is Salt mines. So Salt is a server, like a master and minion. It has an agent that runs on your minions. Those are the little, like your app servers and your fleet that you're managing. The master is going to be the main server that's going to do all the command and control. Minions typically don't talk to each other. They only talk to the master. And if you want one minion to understand data about another minion, that can happen through what's called the salt mine. So if you ever see the salt mine referenced, you'll see here I'm doing a mine.get, basically targeting the salt mine, pulling back addresses for the load balancers that match a specific glob, in our case, dev or local slash HA proxy. Once I've got all those servers ready to go, I will do a loop. So you see right here, we've got 4 app and app servers. We just loop over each of the app servers in turn, releasing code to them one by one. With orchestrations, you can actually loop over and stop. If any part of the orchestration were to fail, you can say that this has to bail out here and continue no further. Because what's the best way to destroy a production environment? I guess, what is it? To err as human, to really mess up requires DevOps. And luckily, this can stop destroying your environment on the very first instance that it finds into a failure. So that's one of the things we put in place here as well. So here's the load balancer. As I was mentioning earlier, the support for all the various kind of platforms and tooling we're already using in our environment. SaltStack supports talking to HA proxy directly. So we just call HA proxy disable server. We're not having to like shell in and talk to a socket. SaltStack is doing all that for us on the backside. We tell it, what app server and what backend we want to actually pull out of the load balancer. So this takes, the first app server out. It will stop the instances using the supervisor D module. It will get what branch of code is supposed to be released, because you can actually pass that in as a command line argument. Normally we have the master branch released into production, the dev branch released into dev. But if, for example, you needed to roll back, you would be able to pass in the hash that you got from the status command into this script, and it would release that specific version of the code out to whatever environment you're targeting. So now we've got our branch and our server, we can release that code. Now, after code has been released, you're going to want to, well, in this case, it does the git pull. For this application, because it's Plone, it's using build out to grab all the eggs for the Python application and put them into the basic working directory for the app itself. So it runs that build out step. For example, the application also uses gulp. So we're going to run npm install to make sure gulp is installed. If it's not installed, it'll get installed at that point in time. Then we run gulp against the server. We will start the instances back up. And now there's a really cool trick. We can actually put in things like test sleep or wait. Actually, we could probably enhance this specific orchestration. Salt has the ability to loop and wait for a network port to be open. So right now we got just a plain old test.sleep in here, just for simplicity's sake. But if you really wanted to make this sophisticated, you could sit and loop, and I'll show an example of doing that loop until the network port is available, and then enabling it into the backend application server. So then it moves on to the next app server. It's taking one out, putting one back in, taking one out, put one back in. Let me show you an example of this, though, using the cloud, because right now what I've shown really doesn't interact with any cloud resources. So it's a similar project using the same code base, but we're going to be releasing to AWS Cloud. So SaltStack has cloud functionality built into it. It can actually talk to many different clouds simultaneously. So if you are doing some kind of a cloud agnostic or hybrid cloud solution, SaltStack may actually be interesting for you to look at. It's similar to tools like Terraform. We actually use SaltStack in concert with Terraform. So Terraform sets up infrastructure. SaltStack then orchestrates things like the release process. So this release process is very similar. If you kind of come up here, it should look really similar. Let me make this wider so you can see it better. We're going to find things like the app server, but we're also going to now be using EC2 for load balancers. So we're going to have ELBs. So we have a pre-check, and so SaltStack supports the Bado APIs out of the box. We can make sure that the load balancer targets are healthy before we move forward. So there's a pre-check here, looking to see, expecting a healthy response in the data coming back from EC2. And we can now deregister our targets once we've determined that all is well, and we can move forward. So just calling it ELB deregister target, we're going to pass it the specific instance that we're currently looping over for the release. So we have multiple application servers running in EC2. We will pass in a specific one to deregister it. And we can basically now, we want to wait, because the ELBs will be draining any existing connections out. So we want to wait until no more active traffic is coming across to that EC2 instance. So this is a little more advanced than the previous example where we looked at, where we didn't do any kind of checking to make sure the load balancer was off before we actually move forward. In this case, with the Bado integrations in SaltStack, we can actually do a health check and wait to see if our target is coming back as unused. So this will loop, just sitting in a loop, pulling, and you can see here we got a period of 5 seconds, and it'll time out after 60. And if it doesn't ever drain fully in that 60 seconds, you see we've got the hard fail equal true, which means it'll just stop right here and not move forward with trying to attempt the full release, because we may actually end up in a state where we don't want to be. Again, same thing, stopping instances, checking out code, releasing code. This is exactly the same as the previous release process. Then when we get down to the bottom, we will now register our instance back in, and then we wait for it to be healthy before we move on. So we don't want to serve traffic if we happen to have an unhealthy backend. So we actually wait for the current instance to turn healthy and start serving requests before we actually move on to the next app server. All right, David is asking, this seems approachable for someone with a Python background. How have you found the learning curve for those who do not? I'd say the learning curve is in a different place. Right now I've not shown one line of Python. Really, we're using Jinja templating. I mean, that's what these variables really are right here, is Jinja templates. We're not having really any Python code. There's a little bit of Python code up here at the top when we're doing these sets right here. There's not a lot of Python code in SaltStack that you would interact with on a day-to-day as like a DevOps person, unless you really wanted to build your own modules, which you probably do. At some point, you're going to want to build modules for pieces that SaltStack doesn't support out of the box directly. Maybe you've got some kind of custom load balancer that they don't support and you want to be able to talk to it over an API. You can do that. Building a module just requires you to lay down a little bit of Python. There's an API you follow, and if you follow that API and deploy your modules into the same code repository alongside your states, you'll now have extended the functionality of SaltStack really easily. I think there's a big learning curve on SaltStack when it comes to all the various concepts and what is the right way to do something. And I don't think this is unique to SaltStack. A lot of different types of software have this problem, and it's a problem of SaltStack is very powerful. SaltStack also is very complex because of that power. You have a lot of rope basically to hang yourself. Simple tools that do one job are very easy to understand because we can kind of put all that knowledge into our head, where SaltStack has hundreds of modules and hundreds of states that are available, and there's just a lot of features and functionality in here because I'm not even covering, I'm just barely scratching the surface when it comes to a lot of the features and functionality of Salt. I used the word reactor so that we can react to events coming across the 0MQ bus. But there's also things like beacons. You can set up beacons inside of any of your application pieces, and those beacons will basically put events on the event bus that your reactors can now react to. There is all the whole infrastructure cloud pieces. There is all the Botto and cloud modules for interacting with the cloud pieces. And being that this is an open source project and has grown pretty organically, not all of them share the same level of consistency. Some of the modules maybe have a method invocation signature that's a little bit different than what you might be expecting if you've been a long-time Salt user and only used a certain subset of the Salt commands, and you now go venture over into their area. Not that I want to dissuade anyone from checking out Salt, but know that there's definitely a learning curve, and I'd recommend that you start out simple. You can manage one configuration file on one server with Salt to kind of get a feel for how it works. Actually, to get a feel for how it works, what I've done is set up a local instance of Salt and Salt Master, and then I use Vagrant. Not up here. So anyone who's familiar with Vagrant, Vagrant is a really cool tool for running a local version of your environment or a local dev server that matches what your target environment may be. If you're developing on Windows, you're developing on Ubuntu, you're developing on Mac, but your target release environment is going to be Linux. There are possibly edge cases you may not catch because your environment doesn't exactly match what the production environment is. With Vagrant, I can match exactly theirs. Like, for example, I am not running Xenial 64, I'm running a newer version of Ubuntu. But I can now run a Xenial 64 instance very easily, actually a cluster of instances in this case, and share into it my code. So you'll see I am actually sharing that Salt formulas and pillar data from my local machine over NFS into these Vagrant machines. And then when I make code changes locally, those now get reflected inside the machine, and I can actually test all of my settings, all my pillar, all my state, all the things I'm trying to attempt to do before I push this out into the dev environment or the production environment. So with Vagrant, a lot of times people set up Vagrant and they typically set up one machine. Vagrant actually allows you to set up many machines. I'm setting up a Salt Master. I'm actually going to set up a load balancer. I will set up an app server, and then I'm setting up, actually, that's not the app server. Oh, there's the app server. And then I can set up, for example, I'm doing a master slave setup of Postgres, and I want to simulate failover locally so I can try out my orchestrations to make sure that the high availability, the slave repair scripts, those kinds of things all work. And so I actually loop through setting up 2 DB servers, and then I can test all of my orchestrations around repair and failover and update locally before I ever get into any other environments. So here's is actually looping over. So I'm creating 2 DB servers, an app server, a load balancer, and a salt master. So I've got a cluster of 5 machines spinning up just from this one Vagrant file that's not even 130 lines long. Actually, what's this one? Oh, that's all the online stuff. Any other questions or anything I can demystify about Salt to folks? Certainly someone else has got something they'd like to hear. Or maybe people just want to be soothed by my voice, talking about random nothingness. See Kim's typing something. See what else may be of importance or relevance here. I showed an example of the code release, but you may also want to do things like orchestrate the retrieval of production data. This actually, yeah, Caleb's right. So actually, Kim was asking if there's something we can like play with. There is something out there that I did set up. Let me go to that right now. On my GitHub, oh, I can't type. Let me reshare this screen. If people did want to play with something, try something out, or at least even see an example of that Vagrant file, I do have it available. If you look on here, oh boy, what's it sharing? All right, that looks like it's, there we go. Yeah, so on GitHub, if you go to github.com/CalvinHP, there is a Salt orchestration demo here. This repo has a light version of kind of what we're looking at. It's a little old, I haven't touched it in a few months, but it does have the Vagrant file. It does show you how to do all the things I just showed you with the Salt Master, DB servers. In this case, it's actually spinning up multiple application servers and then a proxy server to load balance to them. There are examples in here in this Salt orchestration demo repository of doing a reactor and orchestration. So if we look in roots and come in here to reactor, for example, there is a reactor in here that is looking for when a minion gets removed from the cluster, it will automatically call the state.apply against the proxy so it can rebuild what backends are available. So this is actually a Django app and not a Plone app. The other one in here will basically do the same thing. If a application server comes online and does a state.apply, which basically runs the state templates against the application server, it will then also run that state.apply again to refresh what nodes are available for the load balancer. And if we look at Pillar, that may not be as interesting. There's not an actual orchestration in here, but for example, when the load balancer state runs for the proxy, it will apply these things. It will make sure HA proxy controls there, HA proxy is installed, and the magic bit about adding new nodes into the backend or into the front end is right here. It basically will reproduce the HA proxy config file. If the HA proxy config file changes, which is, you can see right here that the HA proxy service is watching. There's a whole extensive requisite system built into Salt that allows you to watch files. So a service can watch a file. If that configuration file changes, it will help the service and keep on rolling. So this is watching for changes. And if we looked at that file over here, down at the bottom, basically it looks at that server mine. So as a new Django app server comes online, it's going to register some data with the mine. This will loop over every bit of that data in the mine and add in a backend server for every application server that's available. All right, Hendryx-Parker, you mentioned using both SaltStack and Terraform with the overlapping functionality between the two. How do you choose which tool to use? Oh my gosh. So anyone who's familiar with AWS, and I got a few minutes left here, anyone who's familiar with AWS knows that it is a moving like quicksand of APIs that change. Even their own documentation doesn't really keep up to date as quickly as the environment changes out from underneath them. I would say that all the infrastructure building and pieces we handle with Terraform because they've done a better job, I think, of keeping up with the API changes for the various environments. So anything that deals with building out of cloud resources and infrastructure, we put that into Terraform. Anything that deals with event-driven orchestration or being able to orchestrate releases or common tasks, we put those things into Salt because that's really not an area where Terraform has a lot of power. Terraform can build up the infrastructure, but then once it's there, it's kind of just there. It can destroy it if it needs to be changed, but it's not really putting states or building out like the dependencies onto a server that maybe need to be there. So you may want to actually use Packer to produce some kind of a VM golden master, or maybe using Docker, and you're going to use Docker or Kubernetes for that kind of piece of the setting up for your application. But all the infrastructure pieces happen inside of Terraform. So Josh Qualls has asked, why Salt instead of Chef, Puppet, and Ansible? We actually, it's funny because you asked that question and Hendryx-Parker just asked a question. Ages ago, I can't remember how many years ago, we actually did a comparison, kind of a cook-off between those tools, including a couple others like CF Engine, BCGF2, and a few others. And at the time, we liked it a lot because of its remote execution model. A lot of those tools like Chef and Puppet are great for the configuration management piece of it, but we really wanted to be able to treat our environment like a remote execution environment where we can also gather data about compliance. So I want to know how many interfaces are in a specific network, and I can gather that kind of information and data in an interactive way with Salt, in addition to being able to do just plain old configuration management. I also really like the event-driven orchestration model. Being able to use reactors like this, we can actually have it react to changes to the environment and do things like automatically heal or whatever. I also liked it because it was written in Python so that we could actually extend it and do more things with the platform itself. That's the main reason we chose it. Ansible wasn't nearly as popular at the time, and I still don't think it has a lot of the features that make Salt really powerful. The issue is those features that make Salt really powerful also make it a little harder to approach for new folks coming to the platform. I think that is all of my time for this demo, and I don't want to like drag it on any longer than I have to. Plus, I know the IBM folks are going to come on in about 15 minutes, and I'm sure we can give everyone a little break to go grab lunch. Thank you for indulging me in my come watch me sit at a terminal and just show you some cool stuff and some cool text on the screen. I will be around